Welcome to a session on Plot the Dots, which will be about run charts. So what I'm going to try to do is tell you why all the statistics you learned in school aren't really applicable in the real world. So traditional stats go out the window. I will tell you, forget everything you've learned, and many of you will say, don't worry, we already have. Well, good. And the most important thing with the type of statistics I will teach you, as you will see in this and the other three lessons, is to plot your data. Some of you might become a shock to you or to many of the people you work with, is I'm going to show you why trend lines are worthless. Yes, worthless. So what part of no more trend lines ever don't you understand? And I'm also going to kind of introduce you to the fact that I know many of you are knee-deep in root cause analyses, and I might have a way to show you whether you're making a difference or not. So with that, there are the objectives, the power of plotting data over time. I've done these in groups as large as 200, and I have everybody on the same page within about 10 seconds for a different conversation. And the important lesson here is to introduce you to the concept of common cause. There are two kinds of variation, common cause and special cause. You treat one as the other, you actually make things worse, and it is the human tendency to treat all variation as special, and you'll get a lot more about that as I go on. Okay, so here's some made-up data. I'm going to get all your former habits out of your system. Let's say this is 30 weeks of data, and this is your typical 6-month how we doing meeting on length of stay. And let's say you have 3 hospitals, and their computer system all interconnects, so everything's defined the same. And at the end of the week, they somehow put in patient numbers and patient days and come up with an average length of stay. So this is the 6-month meeting to say, how are we doing regarding that? And as you'll see, here's a summary. And right now, all of you are looking at the 3 means. And some of you are ranking them 1, 2, 3. Some of you are saying, there's no difference. Some of you say, gee, I'd like more data. And many of you, because you've been to meetings like this, are going. So let's see if you, and all of you probably have belts of some kind, yellow belts, black belts, who knows, going around your organization, and they might want to get their hands on this data. So let's see. Let's do the 3 histograms. Well, look at the shape. And this is the other thing you remember in your statistics class. Notice they're all bell-shaped. Yes, the normal distribution. And, oh yes, we do have tests for normality, and they all pass. So what someone might say is, because they all pass the test for normality, I can do the analysis of variance. And there is your almighty p-value, and the 95% confidence intervals. And from this p-value, since it's greater than 0.05, we can say statistically there is no difference among these 3 hospitals. That's what you might think. Well, when you do a statistical analysis, you are making an assumption about how the data were collected. And in the real world, that assumption is not always safe. So one thing we do know about this data is it's weekly data, 30 weeks of data. And the most important thing you're going to learn in the real world is, why don't we just plot our data over time? So for each of the 3 hospitals, let's plot the data over time and just take a look. So we just concluded no difference. What would you say now? Now, here's my point. Within about 5 seconds, all of you said, whoa, there's no difference here. And by looking at the shapes of the graphs, you're going to start asking some questions. Now, I want to ask you, just given this summary, what do you ask? Given this, what do you ask? Given this, what do you ask? And my point is, there's no fancy statistics here. All we did was plot the dots. But we're going to have a much more productive conversation. So I hope you're intrigued. I had a friend who was implementing a guideline in a 5-state area, and she sent me this data. She called me and she said, Davis, I want to know how I'm doing. This is a true story. And I didn't do this. She didn't do this. But I know some places you'd go and you'd see a poster session where they would put the data and put a trend line in and said, okay, her goal was to get from 50 to 75%. Let's take a look. Well, let's take a look. Look at this. Look at this. And it looks like in about 3 or 4 more months, she's going to make her goal. And you have things like an R squared. You have that wonderfully significant p-value. And it's wrong. And I'll show you why. Here's your bread and butter tool. It's called a run chart. Couldn't make it any simpler. And all it means is you plot your data over time, and you put the median in as a reference point. Yes, the median. The question we're trying to answer here was, did our process have one needle? You'll hear me refer to the process needle quite a bit, which is sort of its center line. Okay, so simple concept. And I want to define one thing, because the word trend is bandied about quite a bit. I'd like to banish it from corporate language. Let's consider 3 data points. They can manifest in one of 6 different ways. Now, if you look at the top one and the bottom one, they fit our prejudice as to what would be a trend. So think about this. If I want to call 3 points a trend, can't you see that's 2 out of 6 possibilities randomly? So in other words, if I want to call 3 data points a trend, there's a 1 in 3 chance I could be wrong. And we see this every month. We go to meetings and we get this month, last month, 12 months ago. What about the 10 months in between? Or you have quarterly review meetings where you get the 3 months of the quarter, and you get this quarter, last quarter, same quarter last year, with this month, last month, 12 months ago, and who knows what else, and bar graphs and trend lines. Here's my point. 3 points tell you nothing. And I'm also going to redefine for you what a trend is, mainly to show you what a trend is not. So when we get the run chart, we're going to have 2 different tests to apply. Number 1 is the trend test. And the way a trend is defined is 6 successive increases or 6 successive decreases. And you're going to find this to be quite rare. And what I'm going to show you using my friend's data is it usually indicates a process that's in transition. In other words, it's not going to continue. So that's the trend test, and you're rarely going to see it. Okay, here's the test you'll use the most. You plot the data, and if you can circle a group of 8 points, either all above the median or all below the median, that indicates that the process has had a shift. And if you think about improvement, what you're trying to do is shift your process to a more acceptable level. So this is going to be your most common test, And it's also the reason why in improvement work, I don't want a huge random sample. I want more frequent samples over time. That's going to be the biggest change I'm going to ask you to make. So you might have quarterly data, in which case I'd say, give me the 3 months, or even give me the 12 or 13 weeklies. And this is where people get a little nervous and say, well, you know, it won't be very accurate. That's okay, because as you're going to find with my kind of statistics, as long as the number is defined in a way that is consistently inconsistent, we can work with it. And you'll see why I want multiple dots. This is one reason, because you want to know very quickly if your process changed. And if you make a very good change, of course, you'll want to detect it as quickly as possible. So bear with me, and let's go on to the next slide and apply it back to my friend's data. So let me make a run chart of her data. Well, first of all, there is the run chart. Now let me show you how I got the median. Here's my friend's data. What I did in this column was to sort it. So we had 23 numbers. So I sort them from high to low. Sorry, we had 22 numbers. And since it's an even number of numbers, if I come to it from each side, they're going to meet in the middle. So the median in this case would be the average of the middle two numbers. If you have an odd number of numbers, it will literally be one of the numbers. So I draw my friend's data, and notice how your eyes act totally different from before when we had the data without the connecting line and added the trend line. You can sort of see here that she was at 50%. She had the intervention here. Well, let me continue. Let me continue. So she intervened right here. Now notice, 1, 2, 3 increases. It's not the 6 increases we'd need to declare a trend. So we can't use that rule to declare a special cause because she was trying to create a special cause, an intervention that got her greater compliance. So the trend rule doesn't help. Well, now you notice that if you look here, the first 9 points are below the median. That is a signal that there was a shift. Now notice also that the next 10 points in a row are above the median. And that is also a signal of a special cause. She tried to create a special cause. All I need is one of these signals. I happen to get 2. So this is the evidence that her intervention has, shall we say, bumped the needle. Now, one of my favorite expressions, and I'll probably say it several times over the course of these 4 lessons, is your process is perfectly designed to get the results it's already getting. So for example, here she had a process that was perfectly designed for 50%. She made an intervention, and it transitioned to what it was perfectly designed given the new inputs. And if you kind of mentally draw a little needle in there, you'll notice it leveled off at about, say, 68%. So here's my point. The trend line said 3 or 4 more months, she'll have the goal. Well, what this says is if she continues to do what she's doing, she's going to stay at about 68%. She needs another intervention. So that's an important point. And also the reason, this also shows the reason why I use the median. Can you see that taking the average of all this data doesn't make sense? So by putting the median in for the run chart, it answers the question, did this process have one needle while we studied it? Or in other words, was there a shift or not? Because if there was, it doesn't make sense to take the average. This is like saying, I put my right foot in a bucket of boiling water, my left foot in a bucket of ice water. On the average, I'm pretty comfortable. So this is what we use the run chart for, to say, can we take the average? So as I just said on the chart, and this shows it more visually, we had a process that was perfectly designed for 50%. She intervened, there was a transition, and it leveled off to where she is now perfectly designed for 68%. So I now have a baseline so that if she makes another intervention, we can see whether she bumped that needle to achieve her 75% goal. Now, what it's going to take in this case is a common cause strategy, which will be my lesson 4. So we use to determine, and here's the point about a good intervention. It changes too fast to observe the trend, and that's a good thing. And that's why we have this backup test, which is what you're going to use the most, and which, as you see, is why I'd rather you plot more dots. So to kind of summarize, to interpret this situation of my friend's data, the intervention is trying to create a special cause to improve the performance. We only saw 3 increases, so we can't use the trend rule to determine it because the process changed too fast to observe 6. But we did observe 9 in a row below the median pre-intervention because we're trying to increase the compliance. And that in and of itself is a signal that the intervention worked. We also have 10 in a row above the median post-intervention, which is another special cause signal to say the intervention worked. All I needed was one of those. I happened to get both. Now, you've all been at these meetings. This is real data, and of course, bacteremias, hospital-acquired infections are big news these days. And I've been at meetings like this, maybe you have too, where boards are very nervous about this. So I can see one board member, if this is presented, kind of saying, hey, look, you trended down and that was really good, and you went back up, and I want to know why. Probably thumping the table in the process. So he's very disturbed about that uptick, that upward trend now. Okay, now, from the trend rule, is that really a trend down? Well, just using the rule, it's not 6. I can't call that a trend. That could happen randomly. And the fact that it went back up, well, that could happen randomly. So it's really difficult to tell what's going on at this point. Now, you'll also see the reason why I want more points. If all I had were those 5 data points, I can't tell a whole lot at all. Luckily, I have all 19 quarters. Thank goodness. Oh, yes, and let me tell you what they did every quarter. I was given this data. This is a place in England. As you see, the current quarter's result is 5. So you know what they did every quarter? They would have a meeting, and in this case, they would pull those 5 charts, go over every single one individually, and say, here's what we should have done differently. Now, let's go back to my definitions of variation. Can't you see they're treating each infection? Now, infection is undesirable variation, right? They're treating each infection as if it's unique, as if it's special. And that's what you're doing in root cause analysis. You are considering the event you're analyzing as special, unique. But at this point, we don't know that. So I'm going to do something with this data that will allow us to determine that and to say they've done, I think, about 149 root causes if you add those all up. Is it working? Okay. So, oh yes, and you usually have a benevolent board member who will say, well, what's the overall trend? Okay, you tell me. How many meetings do you go to like this, by the way? Okay, so let's plot those 19 dots. So here's the data in its time order. Okay, I have 19 data points. I sort them to get the median. So 19 data points means that the 10th in the sorted sequence is the median because there are 9 smaller, 9 bigger. So I'm going to plot these 19 numbers and put the median in. So if all these 149 root causes were successful, we're obviously trying to drive fewer bacteremias. So we might see a trend of 6 successive decreases going down. Do you see that anywhere in this data? I think the biggest one you see, well, here's 2. Here's another 2. Nothing's even close. So we can't use the trend rule to say we made a difference. Okay? Let's use the other rule. If we made a difference, then I might see a special cause 8 in a row above the median early in the data and or 8 in a row below the median later in the data. We see neither. What has the net effect of those 149 root causes been? You've added more complexity and no value. I'm guessing there have been new rules, new forms, you've had awareness seminars, and it hasn't made any difference. Because you're treating every infection as special, whereas this says, and I know this is going to bother some of you, you are perfectly designed to have this level of bacteremias. Now, that sounds flippant. It is not. The bad news is you're perfectly designed to have bacteremias. But that's also the good news, as you're going to find as this series of seminars goes on. You don't need a lot of data to solve it. So, no special causes and a lot of work. This summarizes what I said before. Did we see six successive decreases anywhere? No. Did we see 8 in a row above the median early in the data? No. Did we see 8 in a row below the median later in the data? No. This is common cause. It's systemic. So we've been treating common cause as special cause. In fact, the famous quality giant, W. Edwards Deming, had a specific term for that. He called it tampering. The human tendency is to treat all variation as special. So in other words, every difference between these data points is treated as special. Whether we went up is considered special. Whether we went down is considered special. Every infection is considered special. That is the human tendency. By plotting the dots, we're saying, no, this is common cause. We're perfectly designed. Don't worry, we can deal with it. As a matter of fact, I'm going to put your brains to work in a different way. Rather than ask, why did we have 13 this month and 7 last month? Oh my gosh, we doubled the number of infections Find out why. You're smart people. You're going to find out why. That's a waste of your energy. So they have now done 142 root cause analyses. And we didn't observe any of these special cause tests. The alleged downward trend that the board member was upset about from the year 2002 to 2005 is not a trend. All this work has made no difference, probably added complexity. So now, the common cause strategy, I know some of you are wondering, well, what do we do instead? What this means is, since the same process produced it, you can take all of these bacteremias, put them all together, and then slice and dice them. So in other words, I don't want your brains to tell me why did we have 14 versus why we had 7. I want to say, give me some ways we can take these bacteremias and pull them apart, because quality improvement theory also says we need to apply the Pareto principle. What are the 20% of the reasons that account for 80% of these bacteremias? So kind of a change in mindset. Otherwise, we apply a lot of vague solutions to a vague problem, and we get vague results. And oh boy, are you going to hear me say that a lot. In my next lesson, I will show you that we can also, you've got to say, well, Davis, there's got to be a point at which the difference between 2 consecutive months is too much. And look, given that we're fluctuating, how many could we expect in a quarter in terms of a maximum or a minimum? I kind of want to know then what do we expect? Okay. I'm glad you're all sitting down. If you do the math, and that's what my next video is about, you will find that the average, I think, is about 8.4, and you are designed to get between 0 and 20 bacteremias in any one quarter, and that one quarter can differ from the previous quarter by as many as 17. Now, you may not like those numbers, but those are the numbers. That's what you are perfectly designed to get. You don't have to panic, because despite all that variation, it is not out of control. You can do something about it, and I just told you what to do. We put all those bacteremias together and find ways to tease them apart. I have a saying, I'm the statistician, I know nothing. You're the healthcare people, you know too much. That makes us a good team. I've kept you out of the data swamp of chasing your tail. So there you go. Any one quarter, 0 to 20. If all you do is continue to do what you're doing, tick, 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 there's a 20 waiting for you. If all you do is continue to do what you're doing, tick, 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 there's a 0 waiting for you. You'll probably buy everybody pizza and say, you did it that month, do it again. Well, guess what? You were lucky. And the math to do this, as you will see in the next video, is so simple, it will astound you. It's a matter of, can you subtract 2 numbers? Now, here's the most advanced technique I'm going to teach you. It may involve some borrowing. So can you subtract 2 numbers? Can you sort a list of numbers? Can you multiply and add? That's the only math I require. And watch your conversations change. This is a true story. Somebody once gave me this graph and put in a trend line to show their improvement. And yes, they had the scale from 0 to 100. I took their data. Now, here's their data presented as a run chart. Now, notice, do you see 2 bumps to the needle? And I plotted the data, and I went up to them, and I looked at this data. I said, what did you do there? And they went, how did you know? We had an intervention. I said, oh, and I looked here and I said, and you had another one there. And they said, how did you know? Well, I plotted the dots. So you see, things don't happen as a trend. Things happen as bumps as you change the process. Matter of fact, if you look here at the end, they have some increases, 1, 2, 3. If that continues, they might have a trend upward toward more improvement. We don't know yet, which is why we want more dots. So, I know a lot of you are very enthralled with bar graphs. Everybody is. Here's 4 years of data, not 4 years of data, a year of data on attrition at a hospital. And there were 4 hospitals, and as you notice, for January, see, there's the attrition rate for each hospital. So for every month, they put the 4 hospitals' attrition rate, and the overall attrition rate as a line graph. Now, isn't that helpful? Have you seen some graphs like this? Sure you have. Okay, well, this is data I was presenting to a group of Australian executives, and after they saw my first part of my presentation, they cringed and said, okay, Davis, do your stuff. Within 2 minutes, I went from this to this. I plotted the 4 hospitals' attrition rates and the combined hospital. Now, you'll notice, do you see the bump in the needle at the same place for every hospital? And I asked them, I noticed it happened in July. Once again, I know nothing. I said, ladies and gents, what happens in July? And I got a sheepish, that's the start of our new fiscal year, and we changed the definition of attrition. Indeed, a process change. And you can see it at all 4 hospitals. Now look at this, and look at that. What's going to have the more productive conversation? Okay. Dr. Donald Berwick, and I'm sure you've all heard of him, might be the leading physician advocate of quality improvement in the world. Now, this is a speech he gave in 1995, which I happen to think is his all-time best. And he just talks about the power of plotting data over time. You're smart people. You can read that up there as I make my points. What I like is, just by doing this, the conversations you need to have. Now, notice, he says, first, you have to ask what data to plot. Where are the data? What do they mean? To whom? Who should see them? Why? Think about what you learn when you answer these questions. So I hope I've convinced you to start plotting the dots. Here's one more true story, then I'll wrap up. This was a poster at a conference I was at that talked about reducing NICU infections. And these people had done 149 root cause analyses. And, well, of course that had to make a difference. And it was just a matter of, oh, we have to display the data. Well, let's do it this way. And you've all seen these graphs where the bars are the number of infections on the left scale. The number of patients is on the right scale, and they represent that with a line. And they figure, there, no one's going to question it. Look, all this hard work we did. Well, I happened to see this graph, and I went over there, and I copied the numbers the best I could, and I created a rate. That's the thing with counts. There's a window of opportunity. When you have a count, you always have to create the rate to analyze it. So by looking at the rate of infection, here's a run chart on the bottom. So do you see 6 going down? Do you see a group of 8 above the median early in the data? Do you see a group of 8 below the median later in the data? What's been the net effect of all this work? Nothing detectable. So what they should now go back is take these 149 root cause analyses and do a root cause analysis of these root cause analyses. Now they're going to get somewhere. So I hope you're intrigued. At least you'll start plotting your dots. And as you'll see, this will create a common language, as I hope you have all concluded by looking at this. We want to change conversations. You want new results, you need new conversations. So you need to be able to assess a situation, determine whether you need a special cause or a common cause strategy. Right now, we all tend to default to a special cause strategy that every variation needs an explanation. And you also have a baseline for determining whether your interventions work. The Duran Institute did some research several years ago, and one of its conclusions was many improvement projects fail because there is no good baseline estimate of the extent of the problem. So in other words, we apply vague solutions to vague problems and get vague results. I hope I've shown you of a way to focus. So I hope you can tell I like what I do a little bit. I welcome correspondence from you. There's my email address. I have a website which has links to articles I've written. I've written a book, Data Sanity. And I thank you.